Good morning, Amazers. I hope you're all well and you're doing well wherever you are. So today we'll look at circle theorem, which is key stage 4, and I think this one will do in the 9th grade or year 10. So first of all, let's go over what terms mean in a circle. So we have a circle, and then this one is called the center of the circle. So a line that cuts the circle into two halves is called a diameter. So from here to here is the diameter, and half of it from the center of the circle to any point of the circumference is called the radius. Now this section that is formed between two radiuses, because from here to here is also another radius, this section is called a sector. That part is called a sector. Then this portion, that curve till there, is called an arc. Okay, then we have any line from one part of the circumference to another part of the circumference. That line is called a chord. And then this portion is called a segment. So for sector, I think for sector you're gonna use it to do area part of a circle is called a sector. Okay, so that's out of the way. Now we'll start with theorem number 1. So the angle subtended by an arc at the center is twice the angle at the circumference. So we notice that this is the arc, yeah? So if you have an angle, we have that. So at the center is twice the angle at the circumference. So this angle at the circumference is twice this one. So if this is 2x, this one would be x. Yeah. So the angle subtended by an arc, this angle subtended by this arc, let's say this is arc px, is twice, this is twice the angle at the circumference. So this is the circumference, that's the arc. So these two angles are being formed by the same arc px, but this one is twice of that. Sorry, this is half of this. Now you can draw it a different way. You can even draw it like this. So let's say this is A, B. So that's the arc, this part. So this angle over here is, let's say, 2x, and therefore the angle at the circumference will be half of it. Okay, so that's theorem number 1. So it's good you understand all theorems so that you can apply in the question. Number 2, we have the angle in a semicircle is a right angle. So a semicircle is half of a circle. So we can take either this side or that side. And this is the center. So if we take this top part, if we form a triangle there, so we are saying that the angle in a semicircle is a right angle. So this portion is 90 degrees because this part is a semicircle. It's half of a circle. So that's our theorem number 2. Now the next theorem number 3 is opposite angles in a cyclic quadrilateral. So cyclic is a circle. Quadrilateral is anything that has 4 sides or 4 angles. Is any shape that has 4 sides or 4 angles. Quadrilateral could be something like a rhombus, a square, rectangle, and so forth. So at the center of the circle, definitely we have O. So to form a quadrilateral, and this quadrilateral, the 4 parts are touching the circle. That's why it's called a cyclic quadrilateral. So let's say this is A, B, C, and D. So the opposite angles, so if this is A, this is B, so we can say that A plus B equals to 180 degrees. This is D, and maybe this is C. We're going to say that C plus D equals to 180. So opposite angles in a cyclic quadrilateral add up to 180. Another word for 180 degrees is supplementary. So it can be used, this can mean the same thing as that. So these two sides they give us 180. So if this is 80, this one will be 100. If this is 60, this one will be 120. So that's theorem number 3. Now let's go to the fourth one. Theorem number 4. So angles at the circumference subtended by the same arc are equal. So that's the center of the circle. And let's say we have this arc. So we have this angle. So we have this arc is x, y. And on the same arc we have a different angle. So you see they're both coming from the same origin. So these angles are equal. So if that is x, that one would also be x. Number 5, we have alternate segment theorem states that the angle between a chord and a tangent is equal to the angle in alternate segment. So this line that's touching the circle at a point is called a tangent. So this is a tangent, and then let's say we have a chord. We have that chord, and then we have another chord like that, and another one like that. So we're saying that the angle between a chord, so we're saying this is a chord. The angle between a chord and a tangent is equal to the angle in alternate segment. So this angle, let's say this is angle A, is equal to that one, angle A. And then let's say this is the center of the circle. So this angle on this side, B, is equal to B. Now let's move on to the last theorem. Okay, number 6. Tangent to a circle is a straight line outside of the circle that touches its circumference only once. Radius and tangent are perpendicular, forming a right angle. So this is the tangent. So it's a straight line that outside of the circle that touches its circumference only once. So this one has touched it only once there. And then we have a radius. So remember, radius is half of a diameter. So if you have the radius like that, it forms a 90 degree. So these two are perpendicular to each other, forming 90 degree. So that's the radius. And then last but not least, so two tangents from a circle to the same point outside of a circle are equal. So a tangent, so we can draw a tangent like this. And another one may be going. So they can meet. So when they meet, so two tangents from a circle to the same point outside of a circle are equal. So let's say this is the radius. So let's say that's the radius and another radius here. So here we said it's 90 degree. And also this one is 90 degrees. So we can say that those two angles are equal because the two tangents are meeting. Okay. So those are the theorems that you need to know before you can start doing the examples. Please ignore any noise that is coming from outside of here, and I hope you're able to pay attention. So in your book, I'd like for you to write all the theorems, and then now we can start doing the examples. Let's do a few examples and make sure I've written all the concepts. Now find the value of A. So we can see PM and MQ are tangents. And then O is the center. So definitely this one will be 90 degrees and 90 degrees. Now remember in the previous video, the one on parallel lines, this angle is vertically opposite to that one. So we can see this is 30 degrees. Now as you can see, PMQO is a quadrilateral, meaning it has four angles and it has four sides. So angles in a quadrilateral add up to 360. So we'll do 90 plus A plus 30 equals to 360. So that's 180 plus 30, that would be 180 plus 230, 210 plus A equals to 360. Therefore, A would be 360 minus 210, and that is 150. Therefore, angle A is 150, and therefore here we've applied theorem number 6. Two tangents meeting at one point make them equal, and then this is the center of the circle, so these two are perpendicular, making this 90 degree. Now we can move on to the second example. Now using theorem number 1, whereby the angle subtended at the center of the circle is twice the angle subtended at the circumference. So if this is 150, it's twice of that one. So to find y, we divide by 2, and therefore 75 degrees equals to y. So this one is 75 degrees. So the angle subtended by an arc at the center is twice the angle at the circumference. So 75 times 2 is 150. Example number 3. So still on theorem number 1, because these two are somehow the same, angle subtended by an arc at the center is twice the angle at the circumference. So if this angle at the circumference is 68, this one would be twice of that. So we can say angle POQ is twice 68. So 2 times 68, that would be 136 degrees. So this angle is 136, such that if you do 136 divided by 2, you get 68, which is the angle at the circumference. Number 4. So this is a cyclic quadrilateral, that is ABCD. Is a cyclic quadrilateral, and always start from known to unknown, so we can find this angle because this is a straight line. That's a straight line, so we can say 180 minus 120, that is 60 degrees. Angles on a straight line add up to 180. Now cyclic quadrilateral, the opposite angles, they add up to 180. So even this one we do 180 minus 60, that is 120. Okay. Now remember the lesson on parallel lines. This angle 60 plus this one, they are called interior angles. And the interior angles add up to 180. So interior angles add up to 180. So to find this one, we do 180 minus 60. And that gives us 120. So 120, and then these two are opposite each other, so they add up to 180. So to find M now, you do again 180 minus 120, that is 60 degrees. And here we've we've used theorem number 3 on cyclic quadrilateral. Now for number 5, we're going to use two theorems, that is theorem 2 and 4. Theorem 2 says that the angle in a semicircle is a right angle. The angle in a semicircle is a right angle, meaning it's 90 degrees. So this is diameter, so you have to find the semicircle first of all by finding the diameter. So the angle made here is 90 degrees. Okay, so we've used that one. Now we can go to number 4. Theorem number 4 says that angles at the circumference subtended by the same arc are equal. So if this is our arc DC, it subtends this angle A, and also it subtends this angle. So these two are equal. So we can say that CBD equals to 58 degrees. Therefore, angle CBD is 58 because they are being subtended by the same arc, which is DC. So this angle is the same as that one. Now if you look at this, CDB, it's a triangle, meaning all the angles will add up to 180. And to find D, we just do D plus 90 plus 58, which is 180. So when you add 90 plus 58, that is 180 minus 148. So therefore D equals to 32 degrees. So here we have combined two theorems to find the final answer. Last but not least, we have number 6, and here we're going to apply theorem number 2 and 5. Theorem number 2 says the angle in a semicircle is a right angle. So to identify the semicircle, that's the diameter, and then the angle being formed there is 90 degrees. So that's 90. And then, so of course this one is an isosceles triangle. So to find this angle over here and here, so these two are equal, isosceles triangle. So we do 180 minus 90, that is 90 divided by 2. Each angle will be 45. Now theorem number 5 says alternate segment theorem states that the angle between a chord and a tangent is equal to the angle in alternate segment. So this angle over here, Z, is the same as this. Okay. So using theorem number 5, this one will become 45 because the theorem states that alternate segment theorem says that the angle between a chord and a tangent is equal to the angle in alternate segment. That's why this is 45, because this and this are equal. And if you want to see something, even this one is 90, therefore even this one would be 90. And in reality that is correct because that's the radius and that's the tangent. They form 90 degrees. So this 90 and that one is 90. This is 45 and this is 45. So that marks the end of the lesson, and thank you so much for watching till the end. Please share with your family, with your friends, share with anyone who can benefit from these videos. And if you want to reach me, you can reach me via email or you can DM me on amaze.maths. Thank you so much. Have a wonderful, beautiful day wherever you are, or have a good night wherever you are. Thank you. Bye-bye.